For other uses, see coal disambiguation. Combustible sedimentary rock composed primarily of carbon. Coal sedimentary rock. Bituminous coal. Composition: primary carbon, secondary hydrogen, sulfur, oxygen, nitrogen. Lignite, brown coal. Anthracite, hard coal. Coal is a combustible black or brownish-black sedimentary rock, formed as rock strata called coal seams. Coal is mostly carbon with variable amounts of other elements, chiefly hydrogen, sulfur, oxygen, and nitrogen. Coal is formed when dead plant matter decays into peat and is converted into coal by the heat and pressure of deep burial over millions of years. Vast deposits of coal originate in former wetlands, called coal forests, that covered much of the Earth's tropical land areas during the late Carboniferous Pennsylvanian and Permian times. However, many significant coal deposits are younger than this and originate from the Mesozoic and Cenozoic eras. Coal is primarily used as a fuel. While coal has been known and used for thousands of years, its usage was limited until the Industrial Revolution. With the invention of the steam engine, coal consumption increased. As of 2016, coal remains an important fuel as it supplied about a quarter of the world's primary energy and 2/5 of electricity. Some iron and steel making and other industrial processes burn coal. The extraction and use of coal causes premature deaths and illness. The use of coal damages the environment, and it is the largest anthropogenic source of carbon dioxide contributing to climate change. In 2018, 14.4 gigatons (gt) of coal was used, which is 40% of the total fossil fuel emissions and over 25% of total global greenhouse gas emissions. As part of the worldwide energy transition, many countries have reduced or eliminated their use of coal power. Citation needed: the UN Secretary-General asked governments to stop building new coal plants by 2020. Coal use peaked in 2013, except in China, where it reached higher levels than ever in 2021. To meet the Paris Agreement target of keeping global warming to below 2 degrees Celsius (3.6 degrees Fahrenheit), coal use needs to halve from 2020 to 2030. The largest consumer and importer of coal is China. China mines almost half the world's coal, followed by India with about a tenth. Australia accounts for about a third of world coal exports, followed by Indonesia and Russia. Etymology: the word originally took the form kal in Old English, from Proto-Germanic kula n, which in turn is hypothesized to come from the Proto-Indo-European root ge-u-lo, live coal. Germanic cognates include the Old Frisian kohl, Middle Dutch kohl, Dutch kool, Old High German chul, German kohl, and Old Norse coal, and the Irish word gwal is also a cognate via the Indo-European root. Geology: coal is composed of macerals, minerals and water. Fossils and amber may be found in coal. Formation. Example: chemical structure of coal. The conversion of dead vegetation into coal is called coalification. At various times in the geologic past, the Earth had dense forests in low-lying wetland areas. In these wetlands, the process of coalification began when dead plant matter was protected from biodegradation and oxidation, usually by mud or acidic water, and was converted into peat. This trapped the carbon in immense peat bogs that were eventually deeply buried by sediments. Then, over millions of years, the heat and pressure of deep burial caused the loss of water, methane and carbon dioxide, and increased in the proportion of carbon. The grade of coal produced depended on the maximum pressure and temperature reached, with lignite, also called brown coal, produced under relatively mild conditions, and sub-bituminous coal, or anthracite, also called hard coal, or black coal, produced in turn with increasing temperature and pressure. Of the factors involved in coalification, temperature is much more important than either pressure or time of burial. Subbituminous coal can form at temperatures as low as 35 to 80 degrees Celsius, 95 to 176 degrees Fahrenheit, while anthracite requires a temperature of at least 180 to 245 degrees Celsius, 356 to 473 degrees Fahrenheit. Although coal is known from most geologic periods, 90% of all coal beds were deposited in the Carboniferous and Permian periods, which represent just 2% of the Earth's geologic history. Paradoxically, this was during the late Paleozoic icehouse, a time of global glaciation. However, the drop in global sea level accompanying the glaciation exposed continental shelves that had previously been submerged, and to these were added wide river deltas produced by increased erosion due to the drop in base level. These widespread areas of wetlands provided ideal conditions for coal formation. The rapid formation of coal ended with the coal gap in the Permian-Triassic extinction event, where coal is rare. Favorable geography alone does not explain the extensive Carboniferous coal beds. Other factors contributing to rapid coal deposition were high oxygen levels, above 30%, that promoted intense wildfires and formation of charcoal that was all but indigestible by decomposing organisms, high carbon dioxide levels that promoted plant growth, and the nature of Carboniferous forests, which included lycophyte trees whose determinate growth meant that carbon was not tied up in hardwood of living trees for long periods. One theory suggested that about 360 million years ago, some plants evolved the ability to produce lignin, a complex polymer that made their cellulose stems much harder and more woody. The ability to produce lignin led to the evolution of the first trees. But bacteria and fungi did not immediately evolve the ability to decompose lignin, so the wood did not fully decay but became buried under sediment, eventually turning into coal. About 300 million years ago, mushrooms and other fungi developed this ability, ending the main coal formation period of Earth's history. However, a 2016 study largely refuted this idea, finding extensive evidence of lignin degradation during the Carboniferous, and that shifts in lignin abundance had no impact on coal formation. They suggested that climatic and tectonic factors were a more plausible explanation. One likely tectonic factor was the Central Pangan Mountains, an enormous range running along the equator that reached its greatest elevation near this time. Climate modeling suggests that the Central Pangan Mountains contributed to the deposition of vast quantities of coal in the late Carboniferous. The mountains created an area of year-round heavy precipitation, with no dry season typical of a monsoon climate. This is necessary for the preservation of peat in coal swamps. Coal is known from Precambrian strata, which predate land plants. This coal is presumed to have originated from residues of algae. Sometimes coal seams, also known as coal beds, are interbedded with other sediments in a cyclothem. Cyclothems are thought have their origin in glacial cycles that produced fluctuations in sea level, which alternately exposed and then flooded large areas of continental shelf. Chemistry of coalification. The woody tissue of plants is composed mainly of cellulose, hemicellulose, and lignin. Modern peat is mostly lignin, with a content of cellulose and hemicellulose ranging from 5% to 40%. Various other organic compounds, such as waxes and nitrogen and sulfur-containing compounds, are also present. Lignin has a weight composition of about 54% carbon, 6% hydrogen, and 30% oxygen, while Cellulose has a weight composition of about 44% carbon, 6% hydrogen, and 49% oxygen. Bituminous coal has a composition of about 84.4% carbon, 5.4% hydrogen, 6.7% oxygen, 1.7% nitrogen, and 1.8% sulfur, on a weight basis. This implies that chemical processes during coalification must remove most of the oxygen and much of the hydrogen, leaving carbon, a process called carbonization.